Let's bring the repair of this Mac SE to a close. Warm up the CRT, it's time for another episode. Did you know that 75% of you watching right now are not subscribed to my channel? That's bonkers. Engagement is what makes or breaks a YouTube channel, and I need your help. Subscribe today, and let's build a community together. Alright, so the Mac SE board is back on the bench. A quick review of where we left off last time. So we did a lot of hunting and tracing to find a whole bunch of bad traces. Fixed all of those, and then traced down a couple of little small issues with the video, which ended up being another bad trace, and we got the machine, or we got this board to boot up and run. So that is cool. However, we still got a lot left to do. We still have to put capacitors back in the board. Those are all missing and still out of the board. Maybe deal with this battery and real-time clock issue there. We have to get the serial system working. You know, the entire serial chip is still missing out of the board, along with some of the serial line converters here. The sound isn't working, probably because of another missing trace or a cap that we have to put in here somewhere. And then after we put the serial chip in, we need to test the SCSI, because the SCSI won't work without the serial chip in. It uses it for line control or something to that effect. But before I do all of that, I am going to go back over this board with a fine-tooth comb, really a magnifying glass, and make sure that I did not miss any busted traces. I'm glad I went over this board again, because there are definitely some spots that needed a little bit of rework. The areas here marked with the bright red or bright pink pin are the areas that I needed to fix. There are a couple spaces right here where there were traces, or really the entire via was missing, so I had to kind of run a wire through there to reconnect it. There's a line on the top side of the board here that goes from this pin to this pin that, even though it looks like it's there, it's gone. And since I had already put the sockets in, I had to actually flip over to the other side of the board here and run a bodge on the back side of the board to fix that. Here's that same area again as the front side of the board, but on the back, basically, where things just got destroyed. And it you know, it stands to reason. This is the area right near that that battery, so things just got totally messed up. And I had to do lots and lots of tiny little itty-bitty line fixes and stuff in this area. I also found a section on the front side of the board, flipping back over again, if I can get you in frame. I found one little section right in here, I believe it was, where I had accidentally connected a trace across that did not need to be connected because I misinterpreted how it went together, and I'm glad I caught that, so I fixed that. So now that I have those things fixed, I guess the next thing it would be to put the capacitors back in the board, the big fat ones here, and see if that fixes the audio problem, because I think it might be this capacitor right here actually couples the sound across to the speaker. So let's get those caps put back in the board. Okay, so the recapping is complete. Got all of these in here. These guys here, these are radial capacitors. They're supposed to be axial capacitors, but finding axial capacitors of the value required for these, which is 16 volts, 33 microfarads or something like that, yeah, very hard to find those. As I was doing this process, you know, there's some traces underneath this one, this capacitor right here, that I was worried might touch the leg of the capacitor. So then I went ahead and I took my my solder mask pen, my solder mask repair pen, and started to work in this area. But then the pen snapped in half and almost dumped solder mask goop all over the board. So then you probably saw on the time lapse of me grabbing a paintbrush really quick and then going ahead and doing everything on the board while I could, because that solder mask it dries out over time, and since the container was permanently open, I wanted to make sure I could use it all at the same time. Anyway, I digress. This capacitor right here, a little hard to see, this is a little tantalum capacitor. This is a 10 volt, I'm sorry, 50 volt, 1 microfarad. It's a really weird value that I only have in tantalums, and I only had a little tiny one of, so I made little pop-up leads to connect to that. This probably changes the capacitance of that somewhat, but seeing how we've already tested it with no capacitors in the board and everything seemed to be working, I'm not entirely certain these capacitors are of huge importance. There are also a couple spots here and up here behind the sound connector where there were some regular 100 nanofarad 0.1 microfarad, whatever you want to call them, decoupling capacitors for these chips in these areas that were missing. So I went ahead and replaced those as well. So the next step would be to turn on the Mac and see if we get sound, because I'm pretty sure that this capacitor right here is used as a coupling and filter capacitor between the actual sound output and the speakers. So let's go ahead and test that now. Checking for sound now. Bing! Awesome! It did work. I hope you heard that in the microphone. So that did fix the sound problem. Now I guess I want to go ahead with putting a socket in the board for the Super Serial chip and then testing SCSI next. Okay, so let's get this socket put in the board. I'm going to go ahead and do this one live because, I don't know, because it's fun to watch me solder. I don't know. So get that put in there, make sure it's in the right orientation here with the notch pointed down, of course. Because I have some through-hole bodges going through with some tiny little wires, it's actually going to hold that socket in there fairly well. So let's go ahead and flip the board over. And our socket is right in this area. So I'm going to find a pin. Any old pin I want. I think I want to use this pin right here. And I'm going to tack it in place. And then I'm going to flip the board up and put pressure on that socket while I remelt that, just to make sure it's flush against the board. And then I'm going to do a pin on the other side. So we did this one before, so let's do the one completely opposite of that. Okay, and I do the same thing. Put pressure on the socket. Okay, and that makes sure it's completely flush against the board, and now we just flow all dim joints and hope that there's enough metal in these via holes for them to stick. And that's really the tricky part, is sometimes these via holes, even though it looks like there's metal in there, it's just the tiniest little ring of whatever, and it's just not enough to capture the pin. And in those cases, then you have to run a bodge wire. You have to figure out where that traces pin, pad, via, whatever is supposed to go, and then run a bodge from that location to its final location. These all seem to be taking solder pretty well. I'm just running over them again to make sure there's none that are dry or loose of any solder here. Yep, those look good. That one has a little too much on it. So you just wipe off your soldering iron, retouch it. The iron likes to suck solder up on it, and it sucks the extra out. That was a little weird. That's okay. Alrighty. Again, the trick here too is to have a little bit of solder on your iron. You touch the iron to the pin and the pad, hold it for just a little bit to get them heated up. Then you flow your solder. You want the pin and the pad to be nice and hot because the heat helps it take the solder. If it's cold, you might get a little bit of blob of solder on there, but then you won't get adherence between the solder, the pin, and the pad, and you get what is called a cold solder joint. And it is called that literally because you didn't heat it up enough and the solder didn't do what it needed to do. So again, that's something we want to avoid. We don't want cold solder joints. We want nice, juicy, flowy solder joints. Now, I'm pretty lucky here in doing this because they all seem to be taking the solder really well. So no complaints. I probably mentioned it before as well, but the soldering iron I like to use is a little chisel tip iron because it allows me to kind of dig the point of it into against the pad and the pin at a nice 45-degree angle. It has a nice little surface area to do that, and also holds a tiny little ball of solder on the end of it. I find that it works the best. I don't like little point tip soldering irons. I also don't like the flat chisel tips. I like the pointy chisel tip. Bullet tip, I don't know what you want to call it. It's like a cylinder that's been cut off at a 45-degree angle, if that makes sense. Okay, the last one. Aha, I knew there would be one. Let's see if we can zoom in on that guy. So this pin right here, it does not take solder. There's not enough of a pad there or something. So I'm going to try again. Yeah. I'll take this off a little for a moment. Stand by. I just need to check it closely. I am going to flip this over and solder it from a different direction. It looks to me like right in here. Maybe we can see that. You're on manual focus. So here it is. Let me see if I can get this in here. Yes, there's our problem right here. There's not enough of a pad in there for that to stick to for some reason. So I'm going to do a little scraping action, see if I can get more of that cleaned up and see if I can get that solder to stick. And make sure we're still on frame. Yeah, that works. So to do the scraping, I'm just using a pair of my tweezers here. My super pointy tweezers. I'm just kind of dragging it around the area to see if I can expose some fresh copper on the pad that's left. And as I'm doing that, I just noticed I picked a whole chunk of the pad, whole chunk of the via right off. So yeah, that's the problem. There's just not any metal there to connect to. Flip it to this side. Does that connect to something? It does, so it is important. So I'm going to want to just keep trying it until we get it to stick, basically, is my hope and a prayer here. I think I got it. Yep, let's take a look here. Can you see? Yep, it looks like it took it. Okay. So the next step here would be to take a look at this pin here and trace it over to where it goes and see if I've got a connection between the pin and where it's supposed to go. And if I get connections between pins, then that tells me that we should be okay. So, test this. Yep, that works. So that is between here, and it looks like it goes to that pin. Yep, those are connected, so that pin is good. So now we need to put the chip in the board. And the chip that I am going to use is not the original chip, and I'll show you why. So I got a whole bunch of extra chips here. And this is the original chip, and yeah, that is a mess. That is an outright destroyed mess. So I don't think we're going to try this chip. I'm just going to bypass it. I'm going to eliminate any variables in the testing and just not even use that chip. I'm going to use a brand new one, which surprisingly, you can get these brand new, I think, from Mouser Electronics. You can still buy these chips. It's crazy. So let's do this. I need my chip pin straightener. I'm going to straighten the pins so it'll fit the socket well. Alrighty, and then we're going to put the chip in the socket. There we are. Chip in the socket. So now let's change camera angles, hook up a SCSI drive to this, and see if we can get it to boot from external media. Wah, 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 fail. Yes, it doesn't boot up from SCSI. And based on my diagnostics, or I should say based on my research, that basically just indicates that this symptom here where it seems to work and you get a mouse cursor but nothing happens, usually indicates a bad SCSI chip. Now, in this case, it could also indicate I still got bad traces between the serial chip here and the SCSI chip back here. But based on the way that SCSI chip looks, I think it's probably the SCSI chip. So I'm going to get you in real close, and we'll show you that nasty chip, and hopefully it'll become apparent why I think it's that chip. Yeah, those pins are pretty crusty on that SCSI chip. So I am pretty sure the chip is bad. But no worries, because I got another chip. So let's get that chip out of the board, put this one in there, and see if that fixes the problem. Yucky. Chip came out pretty cleanly. Only one pulled trace here. It was probably already delaminating, so I'm not too worried about that. Although I may have kind of heavy-handed it. Anyway, yeah, let's go ahead and get this trace cleaned up here and then get a socket in. You see that right there? That trace does not connect to that pad. Well, that's part of my problem. So there's that trace all fixed up. This trace actually is important. That connects the EOP, or end of process interrupt pin, on the SCSI controller to the serial chip here through a couple of chips right down there, right off screen. So without that, the SCSI device can never tell the system it's done with the SCSI request. So the system hangs waiting for it to do things. So now that we have that reconnected through there, let's just connect the board back up, turn it on, and see if it works. Yeah! It boots to SCSI. Awesome. Next step, we got to do some testing of the serial. Here is my serial test. As you can probably hear, I've got an ancient Power Mac 75 or 7300/200 running right here, with an old spinner disk in it that really should be a candidate for a SCSI 2SD, but that's for a separate video. But the important thing here is this is running macOS 9.1, and it has AppleTalk and file sharing enabled. I have my username set in here, I've got the computer name and all of that set up, and I have this connected to the Mac SE over there with a simple Macintosh serial cable connected between the printer ports of the two computers. This allows you to set up a very basic local talk network. So let's change camera angles. I'm going to show you the Mac SE, and then we'll see if the two can talk to each other. All right, here's the Mac SE. So to see if it can talk to the Power Mac, we go to the chooser and we click Apple Share. And it requires an AppleTalk network. Okay. It should activate the AppleTalk network. The Power Mac! Yes! If I click OK, it brings up, yeah, username. I don't have a password to it right now. Do I want to connect to the system drive? Yes! It works. So the serial works, and on top of that, full RS-422 communication works. So with that, this Macintosh SE motherboard is fully repaired. I almost forgot. A new battery socket and a brand new battery. And with that, we made one old Mac work again and saved one old computer from the landfill. I'd like to thank Javier Rivera for sending me this Mac SE board to work on, and all of my patrons and subscribers, because you guys help make all of this possible. Thanks for hanging out with me today. Remember to like, subscribe, and ring the bell to stay up to date on my latest adventures. You can also support me through Patreon or by snagging some merch at jcm-1.com. Links in the description. Well, that's all for today's episode. While you're here, check out some of my other videos, and remember, one happy Mac is all you need.